Hello and welcome to the final video of the Excel Expert course. This time we will be doing an Excel esports case I created on my own. So it isn't an official Excel esport case, um, but it's a case I've created for those type of courses. And it's quite similar to Excel esport cases. I had multiple guys, really very well-renowned people in the Excel esport case doing this course and here challenging it. So it's basically like an Excel eSport course, like you would deal in the Microsoft Excel World Championship or the Microsoft Excel Collegiate Challenge. So it's also with the same structure. Um, so here you have a little bit of an explanation. You have here your bonus questions. You have then here also a little bit of other stuff, also with a little bit of explanations and possibly input cells you need to use there. Here are also other things you need to use then. Here are the answers, don't take a look there. And then there are solutions I provided. There are different solutions up until I think 3 solutions for one task. And yeah, to provide a little bit of variety. But the solutions aren't that well thought out. I thought take it on the easy level. For example, Diamond Early solved this challenge with like I think a single formula every time. So yeah, you can do this a little bit more advanced. So first, normally you see here related to, but most of the time, and also I do Excel esport cases most of the time. I start. Sometimes I read the explanations and the initial instructions. Sometimes I don't read them. Yeah, you could do that as you wish. But I most often start with the levels instead of the bonus questions. So yeah, I will start with level 1 and go and so on, and we'll do the bonus questions afterwards. So here we need to find out here the map in which building is the specific cell located. So for example, X22 is in building number 7. But here, if there's no building, there should be entered no building. And therefore we use indirect. So here, indirect, this map, this name, and then this cell will provide us with a number. But if you see if there's a 0 or a W for way or P for parking or S for street, there shouldn't be an a number there. There shouldn't be something there. Instead, there should be written no building. So I don't know if this will work. But there is also text. Yeah, okay. So I use let here, I as my result, and if or I equals 0, I equals W, I equals parking, or I equals street. And then there should be no building, otherwise there should be the result of I. So then check this down, and we solved this level here. So now we need to check in which building the cell is located as before, but and also with no building in when there isn't a location. But now we need to do this with horizontal and vertical movement. So we are starting, for example, here in X22 and going 5 to the right and one up. So 1, 2, 3, 4, 5, and one up, and we're still in building 7. But we could, if we went, for example, 6 steps to the right, we could also be in the nowhere land. So, and therefore, I will do a little bit of side calculations here. So we need address here. The address formula, then we need so the address formula, and then you could also to get the row number of something, you can use your row and indirect, and then you get your row number here and also column and indirect, and you will get the column number. And now if you use this then in the address function with the movement, you will get to your result. So address, row, indirect of this cell value here, plus plus horizontal movement here. Sorry, rows are vertical movement. So plus vertical movement, column indirect to get the column number, plus horizontal movement. And we are in AC 21 as we should be. And now use indirect of all of this, and with the map sheet here, and we are in building 7. Now we can copy this formula here, down here, and copy it potentially, for example, here. And now Control X, paste it inside here. And we now have one single formula to solve this challenge. Oh, sorry, I need to drag this down here. Shouldn't have pasted it here. And now you see everything is solved. So we get our address. This is the most difficult part. We get our address from row indirect and the summing there, and then we use the formula from above. Now level 3, a little bit more complicated, but this is a quite common case to use something like a movement sequence, also with just errors and so on. This is like something, for example, Professor David Brown, one of the authors for MECC cases, likes to do. I have Lambda for this, a pre-programmed Lambda to solve this kind of challenges, but I won't use it here. Instead, I will show you the manual way. So here we have an error list. This list of errors, this is normally not provided, but I provided you this list here. And what I will now do, name this here. So for example, arrows to have a named range, then HM and vertical movement. So horizontal movement and vertical movement. So with here we haven't done horizontal movement, also not with this one, and with this one we don't have a horizontal movement, and also not with this one. I hope I've selected the wrong. Yeah. And with this we have now we go one up. So horizontally we're going one to the right, one to the right, one to the right, one to the left, one to the left, one to the left. We're going one up, so -1. We're going one up, so -1. We're going one down, so 1. We're going one down, so 1. We're going one down. We're going one up. So I will also name this HM for horizontal movement and VM for vertical movement. So now let's get this into different categories with text split into different cells. Here I have everything here in order. So let's use let here. So M for the movement sequence, then text split M, name this as P, and then use left, sorry. Left for the number, so minus minus left of SP. Therefore, you will get like the number here because 3 and this arrow up will mean 3 cells up and 3 cells to the right, and this will mean 2 cells to the left. And then here also like R for right of SP, where I give out the error, and then we will build our address from there on. So address rows or row indirect of this one here, and then I will do it here with the easy first without any movement here, and then this will hand out x22 as we don't move here. And now we need to add here the movement. Therefore we will use first we want to have the row movement. So row is our vertical movement. So we need to add here L multiplied with x lookup of R in our vertical movement array, and not in our error array, and return vertical movement. VM. So I'm back here with the exercise here, and now we need to look up for R and errors and multiply with VM. This should work. Yeah, we get an error here. Don't know why. Or potentially therefore. Inherit this. Oh, yeah, sorry. Yeah. Yeah, I know. And now I need to sum all of this up here. And then I also need to add this for our columns after the column here to get the address. But instead of VM, I need to search in HM. There was an error. See, it is here plus some LR. Oh yeah, W30 as it should be here. And now we can use the function from above and paste it somewhere here and use the different parts. So here wrap around the address function and use indirect, then map and expression sign and concat it with end, and then I name this I, and yeah, it's solved. Then first paste it here, and now we can drag it down, and you see everything is solved. So what did we do here? We have split it here this into separate values from the so like the extent and the error, then made here our normal formula, and then made here a sum of the lookup for this and the movement for this. I made this here also with a one formula approach, but I thought as we should learned here, I could also do this in one single formula. But with the next question, it's a little bit more tricky, and I will use here a separate sheet for this because I need to use here in data tables. So students have different eating habits, and the student only eats in the canteen, so there aren't expenses for eating besides the canteen. So they either eat the most expensive or the cheapest dish, and only poultry, pork, beef, vegan, vegetarian, or combination of these dishes. And if there isn't a certain dish for this day who fulfills the eating habit, he eats nothing. Yeah, not so realistic, but let's face it that way. So here is an example. For example, if in day one a student only eats poultry and the most expensive dish, and day one there are two different dishes with poultry, so he choose the most expensive dish. At day one there isn't any poultry dish, so the student eats nothing. At day one there is one dish with poultry, so he chooses this, and at day four there are four dishes with poultry, so and both are the same expensive, so he chooses one of those dishes. So I have a sheet here, let's name it L4 for level 4. Here's our meal plan. I will copy the meals here in. These are the days. And now I'll do something, it's called a data table setup. So you normally do something like here, because this is every time structured exactly the same. So example 4, and now I search for, let's do it a little bit more down below. Now I search for price tag eating habit. Now I search for example 4, so this value inside here, and I will have this as an output. So here example 4 is expensive and poultry, and what I can now do is, for example, type in here 80, and it will also show me the different types of different inputs here. So now I'll bring, so now I will copy both the info and the price. No, sorry, in here to have it beside me. Where is it? Here. Let's do it that way. I copy everything. Control C. Control V. Oh, I need to bring it a little bit up. Delete the names. The names aren't interesting. Yeah. So let's do it an easy way. So D1, D2, D3, if okay, now we should do also the most complicated part. So there is also if there is a combination of those. And therefore I will use the search function and do it a little bit number. So is number search for this value inside here. So this true because this poultry. This is true. Oh, sorry. Then I need to drag this a little bit down further, and this also here. So this is everything too because it's beef, poultry, or pork. But if you check this a little bit down, for example here, vegan, vegetarian, or also vegan, and our guy will not eat that. And now we will multiply this with the price. Multiply this also with the price for D2 and multiply this with the price of D3. And now drag this down and now use something if this fix it equals expensive, then max of this, otherwise min if s, and this should be larger than 0 because otherwise we would do in 0 here. Yeah, oh sorry, B2 D2. So here 0, here the most expensive, here also the most expensive. Let's try another one who isn't using the most expensive. So here cheap, the cheapest larger than 0, and so on. So, and now we need the total sum here of all of this. And now we were doing the setup for our data table. So 20 rows from number 60 on. Here will be our result then. And now click on data. What if analysis data table. Our values are in a column. And here is our cell we want to paste them in to get the result out. Here, select this. And you see, oh, there's an NA error. Oh, it started with 61. Oh, sorry. Yeah, that could be fixed easily. So let's copy that answers in, and you see everything is as it should be, and you've solved their esport case with a data table. So therefore, data tables can also be quite handy for solving those kind of challenges. So now it's a little bit more, a little bit differently. Nothing to do with addressing, nothing to do with normally here this stuff of the canteen. This time we will be doing something with the course plan. How many hours does a student spend on courses during a week, and ignore breaks and course breaks? So here text split this, then you can see the different courses: Spanish, auditing, entrepreneurship, business research, and so on. And now I will also name this courses, and I think these are all in 1.5 hours structured. So here we can use that as a reference. And now we need to check how often this is here, how often these courses are inside here, and then multiply it with 1.5, sum it up, and you get the time there. And for this we will use map. lambda a, filter courses if courses equals a. We want to have the rows of all of this filtering multiplied with 1.5, and you get the time the students spent in the different courses, because we're all out of different ECTS things. Here this is, for example, 25.5. Oh, sorry. Yeah. And you see it's right. And as you will track this down, oh, too far. You see it is as it should be. So, how many hours does a student spend at the university during the week? Ignore price conflicts. Sorry, course conflicts. Ignore course conflicts, but don't pay attention to the break times. So the daily time at the university is from the start of the first course up until the end of the last course, and you should also pay attention to courses that have been attended several times a week, and also that a course ends with the end time. So let's split this first into separate columns here, and now how do I want to face this? No, I use a data table also here. So here for level 6, and I will copy the whole course catalog in. Then let's name the start. Will this work? Text before the delimiter multiplied with 1. Is this a time? Oh, not +1, multiplied with 1. So this there I get the time, and this plus. Will this work? Oh no. Okay, no, I don't want to multiply this. I want to add this as a time. Yeah, now it worked. So here is the start and the end. Let's format this. Now I will do my normal setup. Example 6. XLOOKUP for this, inside this, and hand out all the courses. Text split this into separate columns, and now we have our courses here. Now I can do something like filtering the filter like the weekday according to those courses. If this equals this course, no, can't use here this because it's the dynamic array. Yeah, but I think the maximum is like 10 courses, so shouldn't be a problem. Oh, there's a problem if you don't fix those ranges here. And then also, I don't think that you need to attend them more than 5 times also on. So I can now filter also a little bit more down instead of the weekday, the start time, and drag this to the right. So And now I will build here I will build here a table. Here are different weekdays, and now I will how can I face this? How can I face this? So you see I did the did this case a little bit more a little long time ago. So you can use something like minfs and maxfs for this. So minimum range of those values if our criteria should be the same size. Please pay attention to this. Our criteria is a Monday. So this is our starting time. The first time on a Monday we need to go up. So here for the business research course. So now let's face this to track it down. So here our start, now our end. You can copy this formula here and instead use maxfs. But you know this is only like the last course start, so you need to add there 1.5 hours plus 30 yeah, plus 130, and now you need to calculate here the difference, track this down, so you have here, and then sum this up and multiply it with 24, and you get 29.5, and the answer is also 29.5. So let's set up the data table. We start with, is this 81? I don't know. You know it's 101. So with 101 we will start. Here will be our result, and there will be data. What if analysis data table? Our input values are in a column, and I click here because I want to have them here. Now it calculates a little bit, and I can now paste those values in here. We have a few errors. Okay, 102. So why do we have those errors? What should be the answer? In the normal circumstances, you couldn't do that. I don't know what's wrong here. Oh, I just saw it here. So I only need to add half an hour if this is larger than 0. If max is larger than larger than quarter of an hour, then no, use let instead. Let of m if m larger than 0 at m plus this time, otherwise return 0. Track this down, and we have our answer. The data table is already recalculated, and we can now post them in. And we have also another error, 114. Yeah, this sounds a little bit not too much. 9.5 here. So you have courses on Monday, 2 courses. also here on Thursday and Friday. So how long is this? 3:15. 3:15. 3:15. I just checked the answers, and this can also happen. So for example, where we're Excel error because Excel has add a few zeros here. So I need here, let's do here around to like 5 times after the comma, and then copy those numbers in, and you see we will not face an error here. So now we have for real a problem or a hard case, because now we need to pay attention also to cross conflicts. So L7 here, this is the same. This is a little bit differently. Example 7. Why is this working? Yeah, it isn't working. Yeah, so now our XLOOKUP, newly structured. So now it's working again. So how many hours of cross conflicts exists? So how do I want to face this here? Okay, this isn't necessary here. This could become handy. I don't know about this. So I've used here the filter and splitting thing from before, and I will use it here for this as well. So I know. So I will use here 2-row, bring everything up here in a single row, ignore calculation errors. So this is here. So let here the dates, or here dates here, and then also for the time. So T2, also the time here. Here, ignore errors here. I need to add T here. And now you have like the time and the dates here as filterable. And now we can filter T if the equals to this day here. Let's fix this here so we can track it down later. And these are our times where you need to go into university. And we will now, this is like F, and we will now search for or count how often they appear. So map unique of the filtered times, unique lambda a columns filter f, and f if f equals to a. And this will hand out how often. So here we have our filtered dates here. So if the date is from their weekday we search for, and with this map function we map the unique of those beginnings and search how often they appear with this lambda columns filter thing and this map function. And now we can track this down, and you see if there is a 2, then they appear more than once. And for these 2s we are searching for, so m, and then sum if s, m, if m is larger than 2, larger than 1, sorry. Oh, sorry, can't use m for this. I must use filter m larger than 1. I have an error here because I haven't something to filter here. So if error, this is 0. Otherwise, I sum this up. Here, for example, on Tuesdays I have 4 course conflicts. But 4 course conflicts, I'll need to divide this by 2 because I've only have 4 course conflicts, and I'm calculating how often the number appears, and now I need to add 1.5 because my hours are 1.5 hours long, and now I can sum this up. So my classes are 1.5 hours long. Paste it here, the result cell. We will start with 121 to start. And you see it has calculated automatically. Let's check. There are a few errors. Okay, now 121. Let's start with this. I have 13 course conflicts on Friday. Okay, that's a lot. So Fridays are here, here, here. So I have there 2 course conflicts, and also here another 2 of them. So in total 6 courses where I have conflicts, and 6 courses, so 4 hours of course conflict multiplied with 1 hour. I screwed this calculation a little bit up. Sorry for that. So with this I get like the total hours of course conflicts. I need to do here with the filter, reduce it by 1. And then, so I have 4 on Fridays. For this I have, because 4 times 1.5 hours of course conflict, so 6 hours, and then divided by 2. Will this do justice? Here, let's check. Also seems a little bit odd. Yeah, also not right. Can't understand my own calculation. That's not so cool. So 121 is still odd. Yeah, and everything is wrong except for the zeros. So I have course conflicts on Mondays. I don't have any course conflict, so this is green. On Thursdays, I have also no course conflicts. On Wednesday, I have 2 course conflicts, here and here. So 2 times a course conflict. On Tuesdays, I don't have a course conflict. Sorry, did the wrong one. Here I have another Wednesday course conflict. Screw this up. So on Wednesday here I have a course conflict as I've did before. On Tuesday I don't have one. And now on Friday, this type of class I don't have one, but so green here. Never mind. And here I have course conflicts also. So here this is red, this is green, and these are four courses of course conflict. So this 2 should be there, not a 2. Instead, it should be an 3 and 3, because two course conflicts with 4 hours, 1.5 hours equals 3, and here 6, because 4 course conflicts 6 hours. So, and with this, so I erase everything I did here. So I have here an 8 and here an 18. This is odd. So instead of summing this up, I use this as an output. So I get 2, 2, 2, 2, 2, and 4. And now I need to divide it. No, I only need the half of it. Or do I? Yeah. So divide it by 4. Add it up. Use if error 0 and multiply it with 1.5. Yeah, 3 hours. Okay. This is odd. 6.5. 675. 4.5. Oh yeah, this could. Okay, there's something happening. I think it's calculating in the backbone. So let's do this data table again. This is my input cell. So 9.5. Few errors here. 975, 1125, and 19.5. So with 121 we have still errors. So these should be 6, instead it's 675. And let's check this. Yeah, and I don't want the sum here. So here we have 3. I see multiple course conflicts here. I should have done this differently. You will see it in the solutions in the back of the exercise that I solved this a little bit differently, a little bit more intelligent in the other types, in the other situations. But I so yeah, but why is there 3? Because I need to yeah, because I've used the filter here, then I don't want I want to have there is 0. So if this is a value, I want to have a 1, otherwise yeah, we don't have anything else. I want here to have a 0, then subtract 2, then sum this up. Use if error also. Extract 2, and this here extract 2 and multiply it with 1.5. Oh, why is there before the if error function? So here minus 2. Yeah, this should now work. 3 on, and here 6. So this should be right. No. Ah, I screwed up here. I screwed up. So, here we are again. And this could often be the case with this type of problems, and you don't get a response for the exercises there. So, yeah, could be quite challenging then sometimes. So, 9 on Wednesdays. So I only have course conflicts on Wednesdays. Copy all the Wednesdays here, all the Wednesday times here. So this to single column, all of this, ignore zeros to single column, and then sort it also. And then here, one course conflict, another one. I think this is the same number. Yeah, another course conflict and another. So 4 course conflicts adding up to 6 hours and not 9. That's odd. Yeah, it's my ugly calculation formula. Possibly the problem here. So here if there is some, I want this. Oh, no. Okay. So I see. Divide it with 2 here, then sum it up. Use the if error function. And now multiplied with 1.5. I don't know if this will solve everything, but yeah, you never know. This has changed a lot. No, I will have errors here. Oh, the same as before. That's not so funny. 121. Oh, we will face this again. Sorry for the mess. Sorry. You can jump to the bonus questions if you don't want to see me here struggling with the solvation of this. So only on Wednesdays and on Fridays. Fridays here, here, and here. So we have 4 times facing those problems. Let's erase everything here. So, but we only get here 6 filtered out. Yeah, 6 is right. So 3 times. Yeah, that's a problem. There should be more. Something is odd here. So this is Friday, this is Friday, this is Friday. Unique F. Oh. Unique F is here. Is the mapping wrong? No, because I have here errors. Here if yes 6, so I have 3 times. No, but I have 4 times the problem. Oh, such a mess. Yeah, so here. No. So why is Okay, I use a function here that you don't know, the drop function, and really erase the first 2 columns and then sum this up and use if error. Sorry for that. Sorry. sum this up. Yeah. If error, oh, sorry, 0 here and then multiplied with 1.5. Sorry, I didn't want to use drop here, but I was forced to by my not so great solution here. And this should work for almost everything. Ah, such a mess. 122. Errors on Wednesdays lonely. All the Wednesday dates. Oh, also here, oh, they're not Wednesday dates. Not this. So here we have 1, 1, 1, and again 1. This doesn't matter. So 4 times an error should be not that much. So here this doesn't matter. So let's take this type here 6. Oh, why isn't this working? Should done this differently. So 8 times, yeah, and I only need half of them. Ah, I see. With the dropping is something wrong. This gets messy even more. I rows of I, so drop from I rows of I the half. Oh yeah, after the bracket. Our columns. So, and now I need to sum this up. If error and now multiplied with 1.5. And this should now work for hopefully everything. One too much. Let's, oh no, I see errors. Errors incoming. 121, 128. So what's causing this error? So I take here the master solution, sorry. So 121. So on Mondays, Tuesdays, so on Tuesdays I have 2 and here I have 4 courses. So Fridays are the problem. Causing the problem. So sum and everything. Drop I will use 111. Why? So use I here. I hands out 2 types times an error. What I have here. So let's take a look at this one is the unique of f is a little bit odd. Yeah, sorry. I see. There are there are rounding errors here because this isn't 41. This should also be 46 to 5. Why? Why? Why are they appearing? That's the question. They only need the start here, and I filter this here. Don't know why. Text before should be for this. Oh no, the unique function isn't working properly. Oh, I see. I made a dumb mistake. Yeah, sorry for that. Unique, and I have here things in columns. So this is causing the problem. I need to debug it a little bit, but 3 hours instead of Fridays. So I don't need the dropping here. So use I here. So for 121, I have here. Sorry, 2 times Fridays aren't right yet. Yeah, so I can't. So now I don't need this here. I can use M here instead. I don't need the drop here. And this should work. It's too much. No. And -1. Has this updated? Oh yeah, now it has. 6.5 can't be. Oh, it has been solved here. So what was my error here? So I can show it to you. Here beside. So F here. Sorry for this. F prints out here horizontally, and if error unique is normally in the standard configuration row-wise and not column-wise. And with this, I've not paid enough attention here for this one and solved it not properly then, because I thought, oh, this would work. But now you see how it's been solved here. So filtering all the different states out and mapping the unique dates, count how often they appear, and then sum them up, except for one, because you have also, if you don't have a conflict, they will be counted, and then multiplied with 1.5 to get the hours here stay there. Now, what percentage, now to the bonus question. What percentage of the map are buildings? So move or copy this, and you can now do something like Control H, format is here, this cell, and replace it with a 1. Okay, this is okay. This wasn't what I wanted to do. So move and copy again. Such a mess. So can I sum if s this is, no, use dynamic arrays here, use it. Some, not some. So this here, and now I check for is number minus minus. Here everything where 1 is, there is a building, so I can sum them easily up. So 2, 4, 6. In percentage, oh, need to calculate the percentage. So these are, so the black doesn't count. So here we have 38 times 46. And now we're 14.1, something around 14.75 F007. So here this is our total map area, and these are the ones with numbers in. So in which cell do you find yourself when you start from ESB 2024 and run the movement sequence from all levels there in total? Okay, and the level is here. So text join those, delimiter first, and then I want this here. I don't need all of this. Sorry, that was the wrong level, I guess. Yeah, wrong level. So here M is this one, and then I should only be the address with nothing else. So here I can also delete I, and then my address cell is that ESB 2024. Also for the column, and you are in EUI. Oh, I think this is wrong. EUI 1229. This is wrong by a lot. So what's the problem here? I selected everything. Yeah. This is splitted properly. ESP 2024. What's the problem? So I now know what my error was. I used the wrong old sequence for the function here down below. Here it was very the problem, and with this my solution is as it was before, right? Here, accept this, We can copy the solution in here. So only hero, indirect, as before, everything as before. No. The only difference is that you concat this and split it then, the concated thing. How much do all the dishes cost in total? Here, this column, and this column. The sum. How many different dishes? Four. No. So unique a stack. No, v stack. V stack. And stack them. Unique will give you the unique list here. It will spill, but now you can count the rows. Here 152. And now we do an XLOOKUP here, XLOOKUP for those values in in only the VStack ones, and return the VStack of the prices. So stack prices also. And this will spill, and now we sum this up. And we have solved everything. So now no errors, everything solved. Sorry for the mess with bonus 2 and level 7. I hope you did better with your run through course. If you have any questions, feel free to ask in the answers. I'm out here. Bye.